Hey, what is up, chemistry people? It is Mr. Boylan, and today we are going to translate among reaction energy profile diagram representations, particulate representations, and chemical equations of a chemical reaction occurring in the presence and absence of a catalyst. So basically, we are going to explain how a catalyst functions in terms of lowering the activation energy of the elementary step in a reaction, and by providing a new and faster reaction mechanism. And two, we're going to define and identify important classes of catalysts, including acid-base catalyst, surface catalyst, and enzyme catalysts. So first of all, what is a catalyst? Catalysts essentially increase the rate or the speed of a reaction by lowering the activation energy of an elementary step in a reaction, but leaves the mechanism unchanged, or it will increase the rate of the reaction by forming a new reaction intermediate and therefore a new reaction mechanism that happens to have a lower activation energy. But bottom line here, catalysts, their goal is to increase the rate of the reaction, speed things up, which could be beneficial for a number of reasons. But as you think about how you're going to have to think about catalysts for the AP Chemistry test, you are going to want to interpret some energy profiles and think about what has happened to that energy profile when you've used a catalyst. So primarily, as you look at this energy profile that's in your notes, essentially it lowers the activation energy, which means that a greater number of particles will possess the required minimum energy, activation energy, and therefore will have a greater number of successful collisions that will lead to the reaction. So notice there that you've got your initial reaction pathway that has a relatively large activation energy. However, notice that with the catalyst, we have reduced that activation energy. If you examine this in a Maxwell-Boltzmann distribution, again, notice that as you think about the number of particles that will have the correct amount of energy in order to react, here we have the activation energy that is required without a catalyst, and recognize that there are relatively few, or definitely less than the number of molecules that have that energy with a catalyst, which is described here. And so note now that we have not only just these molecules that have the amount of energy required, but all of these as well. So larger number of molecules or reactants will have the correct amount of energy in order to have successful collisions. Now, how do we recognize this in a reaction mechanism? Catalysts are going to be present at the beginning of a reaction and at the end of a reaction. In other words, they are not consumed during the reaction. Now, it can be somewhat misleading, though, to describe a catalyst as not taking part in the reaction. They do often react and change during a reaction, but the key thing here is to recognize that they result back or change back, revert back into their original format, and so are not consumed. When you combine the steps of a mechanism, the catalyst will cancel out, again, if it's a reactant in that initial elementary step, but a product in the final elementary step, you'll get it to cancel out. So we don't represent them in the overall reaction, but you will see these in the reaction mechanisms. As you take a look at the sample reaction mechanism that is in your notes, the catalyst is chlorine there. Note that it's present as the reactant, as one of the reactants in the first elementary step, and as a product in the final elementary step. Recognize that it will cancel out when you're trying to describe the overall reaction that's being represented. Don't confuse your catalysts with your intermediates. The intermediate in this reaction is the ClO. Note that it is a product in that first elementary step and a reactant in that second elementary step. A common error that is made is the confusion between catalysts and intermediates. Now, there are three types of catalysts that you just need to be aware of. The first is an acid-base catalyst, where a proton is lost or gained by a reactant, which results in a change of the rate of reaction. Two surface catalysts, for example, gases may be absorbed onto the surface of a metal where reactant bonds are weakened, and as a result, the reaction occurs faster. Also, by collecting reactants onto a common surface in a smaller area effectively increases the reactant concentration, which will in turn mean an increase in rate. And then lastly, we've got enzyme catalysts, biological catalysts, often proteins, with active sites that interact with substrates or your reactants to increase the rate of reaction. So 3 types: acid, base, surface, and enzyme catalysts. And that, in a nutshell, is what you need to know for catalysts for the AP Chemistry exam.